Okay, we'd like to welcome everyone this evening for our MLE Friends talk with Dr. Luisa Damiano. And we'd like just to start out by thanking our friends for joining us this evening. This is an MLE Friends talk, which is really part of a series that was created specifically with you in mind. So thanks for joining us for this discussion. And we'll start out by introducing Dr. Luisa Damiano, and then we will give her the floor for her presentation and her talk. And then our managing director, Gabor Karsai, will be managing the question and answer period for the last 20 or 30 minutes of the evening. So if you have questions throughout the talk, you can either put them in the chat or just keep them and think of them and then raise your hand at the end. So welcome. Thank you so much, Dr. Luisa Damiano, for offering this talk on a very edgy topic of a lot of interdisciplinarity. And it'll be called Social Robotics on the Edges of Brain, Body, and Environment. So Dr. Luisa Damiano is an associate professor of logic and philosophy of science at the IULM University in Milan, Italy. And she's a coordinator of the research group on the epistemology of the sciences of the artificial. Her main research areas are epistemology of complex systems, epistemology of the cognitive sciences, and epistemology of the sciences of the artificial. Since 2007, she's been working on these topics with scientific teams all across Europe and in Japan. And among her publications, there are many, many articles, notably the books Unita in Dialogo in Italian and Living with Robots in English with Paul Dumouchel from Harvard University Press, and several co-edited journal special issues. And so if you'd like to find out more about her research, we can also point you to a link later on this evening. So thank you, Luisa, so much for offering this talk, and the floor is yours.
Thank you very much. Thank you for having me here. I'm very happy to be here. So I share the screen, 1 sec. Okay. I think you see my desktop now, and in a second, I hope now you see my first slide. Can you see my slides? Okay, thank you very much. So thank you so much also for this nice introduction. As was said by Joanna, I'm a professor of philosophy of science at the University, and one of the fields of in which I work is called epistemology of the sciences of the artificial, which is a philosophical reflection on the possibility, the limits, and the ways of contemporary sciences that are studying natural processes, mainly cognitive and biological processes, through the construction of artificial models of these processes. They can be robotic models, can be chemical models, or can be computer simulations. And the seminar I'm proposing to you today is strictly linked to this field, as it is a philosophical exploration of the field of social robotics, the area of social robotics, which in my view is one of the emergent sciences of the artificial, as it produces robotic models of us as cognitive and social agents. Generally, social robotics is defined as a new area, an emerging area in contemporary robotics that is dedicated to the design, the construction, and what is called the social integration, that is the introduction into our social context of robots that are characterized by a property that is called social presence, and is defined as the capability of a robot of generating in its users the impression of being with another or someone. It is another that at the level of its social presence displays features that are typical of or similar to those of persons, and also are characterized by social performances. That is the capability of interacting with us through social signals that are compatible with ours, which does not imply the capability of understanding or interpreting in an appropriate way our social signals, but at least the capability of giving the impression of understanding and interpreting our social signals. This is the meaning of social performances in opposition to the notion of social competencies, which would imply this understanding. And among the social performances are considered particularly important by specialists in social robotics, affective performances. This is the capability of interacting with us through affective signals that are compatible with ours, and in particular emotions. And these are considered particularly important to build the social presence of social robots. So we can see from this preliminary definition that social robotics is a branch of contemporary robotics whose goal is not that of building robotic tools for us. The idea is that of creating for us social partners, interlocutors, that is social, artificial agents, robotic agents that are capable of interacting with us as peers. And this is what makes social robotics particularly interesting from the point of view of my field of philosophy of science, because the activity of creation of artifacts in which social robotics is engaged is articulated around a very interesting research question. That is the question of how we can transform electromechanical objects like robots into subjects of interaction for humans. What are the conditions under which humans recognize and treat objects like robots as social partners? And is, in my view, the way in which social robotics is addressing this question, this issue, this makes of social robotics not only a branch of engineering, building artifacts that are useful for our daily life, but also a science of the artificial, like in the sense I indicated before, that is based on insights developed by other sciences about human sociability, human cognitive processes, and in particular intersubjective cognitive processes, in general human nature, but it can also, through the robots, it builds on the basis of these insights, generate new insights about our sociability, our cognitive processes, and our nature. And indeed, social robotics grounds the effectiveness of its artifacts, the capability of its artifacts of interacting with us effectively through social signals that are compatible with ours, on research procedures that are shaped by the method of reference of the sciences of the artificial, that is called the synthetic method, and was introduced in the era of cybernetics into the scientific practice, and then became the official method of reference of sciences of the artificial, like, such as AI, synthetic biology, and so on. And I don't have the time to enter in details about the synthetic method, but for us it's interesting and relevant to know that social robotics produces research practices through which it incorporates in its machines, in its artifacts, in its robots, scientific hypotheses about our cognitive, affective, and social functioning, and then tests these hypotheses by evaluating the quality of our interaction with the robot it produces, in which it incorporated these hypotheses. And this not only in social robotics labs, but also in the social context in which these robots are introduced. In this sense, we can develop the hypothesis that all the process of diffusion of social robots into our social context can be considered, can be interpreted and studied as a complex experiment, as a network of tests of the scientific hypotheses on us that are incorporated in these robots. And the complex experiments that allow us to know better ourselves, to address in a new way, the way typical of the sciences of the artificial, the key question of who we are. But at the same time, by diffusing in our social context robots that, by incorporating scientific hypotheses on us as cognitive agents, as social agents, as affective agents, are then robotic models of us, this complex experiment is also imposing to us to address other key questions, and in particular the question of who will we become through the diffusion of these robots in our social context, and also of who we would like to be or become through the diffusion of these robots. And in this sense, the idea that I propose to debate this evening is that we can consider social robotics in this sense as a synthetic anthropology, a sciences of the artificial, focusing on us in a strong sense, because it is concerned not only with our self-knowledge, using robots as tools for our self-knowledge, but also with our self-transformation, because these tools of self-knowledge are also tools that are transforming us. This becomes evident if we consider the role that, the critical role that these robots can play in the loop of co-determination that I draw in this slide between, on one side, our scientific self-modeling, that is the scientific views of us as social agents, cognitive agents, affective agents that are proposed by the cognitive sciences and other sciences, psychology, anthropology, epistemology, sociology, and so on. And on the other side, our social context that, through the introduction of these robots, are becoming mixed human-robot social context, so mixed human-robot ecologies. Indeed, what social robotics is doing is incorporating hypotheses produced by cognitive sciences and other sciences on us as a subject of social, cognitive, affective processes in these robots, and then introducing these robots in our social context, following a programmatic view according to which these robots will be introduced not only in public environments like hospitals, schools, stations, commercial centers. We are thinking today to robots that can be educational mediators, therapeutic mediators, helper in healthcare, can give information in commercial centers, can help support, can make marketing, and so on. The idea is that of introducing these robots also in our most intimate spaces, our domestic spaces. We think to robotic babysitter, robotic butlers, robotic personal assistants, robotic lovers even. So this introduction, if it will follow, really will realize this project, will imply significant transformation in our social context, not only transformation in the way in which we interact with technology, because we will interact with these technologies in a way that will be more and more social, but plausibly will transform also the way in which we interact with each other, and also in the way in which we see ourselves as subject of social, cognitive, affective processes, also at a scientific level, closing a loop of co-determination between our scientific self-modeling and our social context that we want to maintain sustainable. And one of the assumptions that are underlying my work, my philosophical exploration, epistemological exploration of social robotics, is not only ethics, but also philosophy of science can contribute to maintain the sustainability of this loop by focusing particularly in these years on the first arch of this loop that is going from the cognitive science and the other science, from our scientific self-modeling to our social ecologies through the introduction in our social ecologies of social robots, because this is the arch that we are structuring these years. And the idea is that of using the tools and the procedures of inquiry typical of philosophy of science to try and understand what models of us, of our sociality, our affectivity, our mind are used today by social robotics to create these robots, are incorporating in these robots, and what are the potential impacts that this model through these robots can have in our on our social ecologies. And the idea is that then of sharing the results of this kind of inquiry, not only with the sciences that are directly involved in the loop I drawn before, but also with ethics and all the disciplines that are involved today in constructing ethical and regulation frameworks for the diffusion of social robots. And today I would like to share the results of this exploration with you, with a focus on the part of this exploration that is dedicated to artificial empathy. With this label, artificial empathy, I refer to the scientific research that is involved always in the research performed by social robotics, that is directed to build robots that are capable of interacting with us through affective signals that are compatible with ours, and in particular through emotion. Robots that are called by the literature emotional or empathic robots. And I would like to spend a few words on this label, why we call artificial empathy this kind of research, let's say the research realized by the robotics of emotion. And this label is interesting because it was introduced not in the field of robotics, but in the field of philosophy of science. We introduced with Paul Dumichel this label to give the title of a project that we were proposing to the Japan Society for the Promotion of Science to study social robotics. And we propose artificial empathy to define this kind of research in robotics focusing on emotion for two main reasons. The first is that this kind of research in robotics reflects and intend to reflect the realization of the embodiment turn in cognitive science and AI. And when I refer to this turn, I want to refer to the transformation that took place within the context of cognitive science and AI that started, let's say, in the late 80s or the first 90s, and led to a change in the mainstream of cognitive science and AI from the classical or computationalist approach to embodied approaches, where for classical or computational, usually this transformation is considered schematical as the transition from classical or computationalist cognitive science to the new or embodied cognitive science, where for classical or computationalist cognitive science we consider the first and classical form of cognitive science, which emerged in the middle of the 50s already with this theoretical orientation, which is defined computationalist because this form of the class of the cognitive sciences is using the model of the digital computer to describe us as cognitive agents. Basically, the main idea is that cognitively we work in the same way of computers. We receive information from the environment in which we are embedded. We process this information. On this basis, we generate internal representation of the environment in which we are operating, an environment that within this approach is considered more or less independent from us. And on the basis of the correspondence between this internal representation and this environment, we can generate effective solution for the problems of interaction that we have with the environment. This kind of approach was leading research in cognitive science and AI since from the middle of the 50s to the middle of the 80s, when a series of difficulties triggered what is at least the proponents of embodied cognitive science called the crisis of computationalist cognitive science, a growing dissatisfaction in the specialists for this kind of approach, for this kind of modeling of us as cognitive agents. We had a search for alternatives, and from the beginning of the 90s, the alternative that emerged is that of embodied cognitive science, which is called embodied because addresses the difficulties met by classical or computational cognitive science, which I don't have the time to describe in details here. One of them was the need of redefining completely the ambition, for example, of computationalist AI, or the failure or the winter of computationalist AI. And these difficulties are addressed by embodied cognitive science by focusing on the role played by the body in cognitive processes. And that's why the label embodied cognitive science and AI. And embodied cognitive science and AI is a plural science, which is constituted by many different research lines, which use different models to describe us as cognitive agents. We have models that are completely different from the classical model of the digital computer, models that are produced in the field of cognitive biology or in the field of the sciences of self-organization, and describing us as a biological system that are self-producing themselves and are characterized by an organization that is not compatible with the architecture of a digital computer. But we still have also the reference, many lines in the embodied cognitive science today refer to the classical model of the digital computer, reinterpreting this model with an embodied approach. So in this sense, between the mainstream of the embodied cognitive science that still refer to the model of the computer to describe us and computationalist cognitive science, there is not a radical distance, but there is a point of discontinuity that is the different perspective on the role played by the body in cognitive processes. The proponents of embodied cognitive science and AI refuse the classical computationalist approach, which in their view neglect or even deny any role to the body in cognitive processes. The idea is that classical computation is still seduced by the idea of a naked, disembodied, immaterial mind that with regard to its functionings is completely independent from the specificity of its material realization. Well, and this is an approach that is radically refused also by the mainstream of embodied cognitive science. And on the basis of this difference with regard to the role played by the body in cognitive processes, are defined the two main differences between embodied cognitive science and AI and computationalist cognitive science and AI. The first is that while computationalism was considering as genuinely cognitive processes only rational activities, language, reasoning, demonstration of theorems, formal games like chess, and was considering all the processes of interaction between the subject and their environment that are related to the body as non-cognitive bodily processes that are obstacling the realization of genuinely cognitive processes. Embodied cognitive science and AI is reintegrating these processes of interaction between subject and environment strictly grounded in the body, actions, intention, emotions, in the field of cognitive processes, and is considering this as basic cognitive processes from which the rational activities are emerging. And there is also a big difference at the level of AI. While classical or computationalist AI was modeling us as cognitive agents through computer programs, focusing on software and not on hardware, embodied AI models us as cognitive agents through the construction of complete agents, that is, agents that are endowed with a body, a robotic body, that is, robots that are interacting with their environment on the basis of processes that are linked to the body, actions, intentions, and emotions. So there is a specific interest for building as models of us as cognitive agents, robots that are interacting through emotions with their environment, also with their social environment. And in this sense, social robotics reflect the realization of the embodiment turn in cognitive science and AI, and is engaging significantly in research on emotions through the synthetic modeling procedures. And indeed, all the branches of robotics that today are involved in research on the kind of research that I defined as artificial empathy before, are all branches of robotics that were developed after the birth of embodied AI, and that define themselves as branches of embodied AI and show a growing interest in emotion. Indeed, for example, in cognitive robotics, we have one of the fundamental ideas principles of cognitive robotics is that emotion and cognition are intertwined from the basic manifestation of cognition in early perception to the highest manifestation of cognition in reasoning. And the interest in emotion in the field of human-robot interaction, HRI, that is a field that includes social robotics as a particular area. HRI is dedicated to the construction of robots that can interact with us. Social robotics is focusing on robots that interact socially with us. In HRI, there is the idea that is expressed here through a sentence by Frank Hegel, who is a researcher in robotics, that in equivalence to Václavic's statement that one cannot not communicate, it has been found that also in human-robots interaction, one cannot be not emotional. We are always emotionally solicited when we interact with robots. This is the idea. The second reason for which we used the label artificial empathy to describe robotic research on emotion is related to the plural character of the notion of empathy, which is a notion that describes different processes, a range of processes that goes from emotional contagion to perspective taking, to theory of mind, but also is a notion that migrating is a notion that migrates among different disciplinary areas, and through this migration is it opens itself to new contexts. So our idea was that through this migration in social robotics and human-robot interaction, empathy would, the notion of empathy would acquire new contexts to describe affective processes. And in a sense, maybe we anticipated also with this label the pluralistic approach, the pluralist approach to human-robot affective interaction that then we developed, and then of which I will talk later on. So what I would like to do today is to present to you and to discuss with you, hopefully, the results of my inquiry into artificial empathy. That is the inquiry on what models of emotion are today used by social robotics to create effective social robots, and what are the potential impacts of these models on our social context. Starting from offering an overview of the field of artificial empathy and trying to arrive to define the implication of this kind of exploration of the field of artificial empathy, of this epistemological exploration of the field of artificial empathy for the ethical debate on artificial empathy. And the typical overview I propose of this field is based on one of the foundational theses of the field. That is the thesis according to which, and the thesis we find typically in the literature of artificial empathy, a thesis according to which in emotions we can find two different aspects that are strictly linked because they co-evolved, they evolved together, but that the robotics can treat separately. And typically the literature defines these two aspects as the external aspect of emotion and the internal aspect of emotion, where the external aspect, that is called also social or inter-individual, is associated to emotion expression that we can realize through facial expression, vocal expression, posture, proxemics, and so on. And the internal aspect of emotion is typically defined also as private or individual, and is typically associated to the production of emotional states and the self-perception of the subject of emotional processes of these states. And on the basis of this distinction and the idea that these two aspects can be treated separately, we have the definition of the main research axis constituting artificial empathy. One is external artificial empathy, which is engaged in creating robots that are displaying emotional expression, mainly. Internal artificial empathy, which is focusing on creating robots that can generate their own emotional states and even perceive them. And then there is a third research line that tries to treat both these aspects, to reconnect this aspect treated separately by internal and external artificial empathy. So let's consider more closely Okay, external artificial empathy and the other two lines. External artificial empathy, it's maybe the most developed of the free research line in artificial empathy, and target the production of service robots that are endowed with the external or the expressive dimension of emotion, to the goal of intensifying their social presence, as I defined it before, and so their social acceptance, to facilitate their social integration into our social context. And this is typically realized through interdisciplinary studies that are trying to create for these robots forms of emotional expression related to the face, to the body, to the prosthetics, and so on, that are stimulating in the users anthropomorphic projections. So the idea is that of giving to these robots features that are triggering in us anthropomorphic projection, that is the projection on these robots of mental properties that are typically human, which is done through by giving to these robots an expressive behavior that is particularly realistic, modeled on our expressive behavior, on the animal expressive behavior, and also an appearance that is similar to ours. This is, there would be a very long topic to develop this one, considering also a very important hypothesis that is used in social robotics that is called uncanny valley hypothesis to build this kind of robots. We don't have the time now, but maybe into the discussion we can go into these details. The relevant aspect for us is that through these strategies, the anthropomorphization strategy, external artificial empathy produces robots that, from the point of view of their cognitive architecture and their performance in AI, are very poor and simple. They have a very rich emotional expressivity, and they have a significant success as therapeutic and educational mediators, especially for children with special needs or elderly with special needs. An example of this kind of robots can be Caspar. This is a robot that was designed and constructed by Kerstin Dauteran and their team, based on the study in depth of the literature about autism in children, early intervention on autism, and ways of effectively intervening on autism. And Caspar is designed as a therapeutic and educational mediator to improve social skills for children, for these children, and more in general, children with special needs, and in particular criticalities in their social interaction. The idea is that of creating for these children, through these robots, protective environment of interaction, in which even when they commit mistakes, like touching with too much force the other, or not recognizing, so not synchronizing with the emotion of the others, they are not rejected by the partner of interaction, but they receive a very clear feedback that can help us to understand, to learn, to understand, to recognize the emotion of the other, their own emotions, to modulate the force in the interaction, and so on. To then use these skills, of course, with other children and their peers, and with other humans. This is the idea of therapeutic mediation or educational mediation. The idea of mediation is also linked to the fact that the children are never interacting alone with these robots. There is always an educator or a psychologist, therapist that is operating the robot, which is not autonomous at all. As you see, the robot in itself is a minimally expressive robot. It has this silicon mask that create a minimal and very a minimal expression, that is an expression that is not subtle, but very clear, let's say, related to emotions that are the very basic, like fear, happiness, sadness, neutrality, let's say. I have some videos that I can show you during the discussion to make you see how the interaction is with these robots. Then we have, for example, these other robots that was created by Takanori Shibata, that is used for what Takanori Shibata called robot therapy, and is considered a sort of substitute, robotic substitute for pet therapy, and is particularly successful with elderly affected by dementia, for improving the relaxation, motivation, socialization, and so on. I have some videos also about this that I will show you later. Let's now consider the other major line of research in artificial empathy, that is internal artificial empathy, which targets the production of robots that are characterized, that are endowed with systems of production of emotions that are modeled on natural emotional systems. That is, they incorporate, based on the synthetic method, our best theories on how emotional processes are produced in animals and in humans. And this with a double goal. On one side, testing these hypotheses. We incorporate these hypotheses in these robots, then we make these robots interact in appropriate environments, and we compare the emotional behaviors produced by these robots with that of the target system to understand how we can improve the capability of our hypothesis to describe appropriately the generation of emotional processes in nature. But also the goal is that of improving our robots. The idea is that a robot whose behavior is controlled by a natural-like emotional system can be more flexible in its behavior than a robot that doesn't have this kind of system. For example, a robot that can feel fear can react quicker to a dangerous situation than a robot that has to analyze all the detail of the situation to individuate a risk and take action to address this risk. And typically the approach through which emotions or theories about generations of emotion in nature are implemented with these robots are approaches that are called systemic, interactionist, or emergentist, because the idea is that not that of creating a module inside the robot, complex module, completely responsible, fully responsible of the production of the emotional processes. But the idea, based on a systemic view of our physiology of emotion, is that producing emotional processes through the interaction of different organizational levels in the robot. The robot itself, some of its subsystems, and environment and systems embedded in the environment. We have different research lines that are engaged in this kind of research, and all converge in considering that the reproduction of our physiology of emotion in robots is a task that is out of reach for the moment, is a task for the future, as Domenico Parisi wrote in a recent book, Internal Robotics. And this, in my view, is even optimistic. We have anyhow some prototypes. Also for this, I have some videos that I can show you during the discussion. For example, this is the robot you see on the right is called Affetto. Was designed and realized by Minoru Osada's team at the University of Osaka, based on studies of our emotional developments, starting from simulation about our emotional developments in the fetal state and following all the further stages. So let's consider now what are the models of emotions that are leading this kind of research. And the first consideration that we can make on the basis of this overview is that external and internal artificial empathy share a theoretical approach to the description of emotion that we can call a dichotomous approach to the description of emotion. As starting from this original distinction between expression and production of emotion, external and internal aspect of emotion, they tend to describe emotional processes through series of dichotomies of opposition, social private, interindividual, intra-individual, but also the opposition falls true in the sense that the literature of external and internal artificial empathy converge in considering that external artificial empathy, by producing robots that do not have any internal machinery to generate emotional states, but that simply express emotion, focus on the expression of emotion, they generate mere simulation of emotion, that is false emotion, while internal artificial empathy, even if it's not able to reach its goal, is targeting a genuine creation of emotion, true emotion. And this kind of dichotomous description of emotion is typical of our philosophical tradition of, let's say, the mainstream of our philosophy of emotion. Typically, the paternity of this kind of descriptive pattern of emotion is ascribed to Descartes and his treatise on the passions of the soul, but his view that is called also subjectivist, internalist, or individualist, is typical also of classical cognitive science, the moderated or the mainstream of embodied cognitive science, but also of the common sense. And if you want really to reduce it to basic points on which all its declination of the declination of the pattern are converging, we can identify three main theses, according to which the production of the emotional states, it's an internal process that is taking place in the intra-individual space, where we find the genuine or true manifestation of emotion, which is accessible only to the subject of emotional processes. According to Descartes, the subject of emotional processes cannot commit mistakes about her own emotional states. And these mistakes can occur only in the interindividual space, which, according to the second hypothesis, is the space of the expression of emotion. Expression of the emotion within this descriptive scheme is considered a process that is secondary to the production of emotion and contingent, in the sense that we can learn to inhibit the expression of emotion, or we can learn how to alterate and to create a divergence between the emotion we are expressing and the emotions we are feeling. This is the idea of false emotion. And in this sense, it is ascribed to this interindividual space that is the space of expression of emotion. And according to the third thesis, when we express our emotion, we allow the others to engage in processes of understanding our emotions, and through these processes, we can influence their emotional state. With a process that I try to describe through this scheme, a very complicated process, according to which basically when the other expresses her emotional state, we can engage in observation of her behavior, analysis of behavior, and theorization that about her emotional state. And then when we arrive to an hypothesis, this hypothesis can influence our process of production of our emotional state. And if we express our emotional state, then also the other can engage in the same kind of process. A very complicated process that does not capture all the phenomenology of our emotional interaction with others, that in many cases appears as a simple synchronization with the other without this kind of observation and analysis. Anyway, if certainly at the theoretical level, both internal and external artificial empathy are explicitly referring to this kind of description of emotion, let's say the Cartesian description of emotion. On the other side, when they implement, when they create empathic or emotional robots, they do not follow this, in my view, this theoretical description of emotion. And they systematically violate the Cartesian border of the process of production of emotion. I try to emphasize this point while talking about the interactionist, emergentist, or systemic approach of internal artificial empathy, which produces emotional processes or plans to produce emotional processes through the interaction between the robots, some of its systems, and the environment, and systems embedded in the environment. So here, the space of production of emotion is not the intra-individual space of the robot, but is the robot environment and other agents unit. So is this space. And the same happens for external artificial empathy, which produces robots without any interiority, any machineries that is there to produce, to generate emotional states for a robot, but they are used as activators of genuine emotional processes in the users, that are users that typically do not have to engage in complicated processes of observation and analysis of the behavior of the robots to come up with hypotheses on their emotional states, but directly react through these genuine emotional processes to the expression of emotion performed by these robots without any cognitive architecture to produce emotion. So also here, the space of creation of emotion is not the intra-individual space, nor not the intra-individual space of the agent, nor of the one of the user, but is again the agent, environment, other agents unit. And also here, expression of emotion and production of emotion are strictly linked. And this scheme is shared in an explicit way also by the third line of artificial empathy, that is called affective loop research line, as it targets the production of interactive robots that are characterized by an intelligent emotional expression that is an emotional expression that is coordinated to the emotional expression of their users. The idea is that of creating between the user and the robot affective loops to offer to the robots, to these robots, a more convincing social presence and long-term capability of social engagement in the interaction with humans, by stimulating the user to effectively answer to the robot and gradually feel more and more involved. And this is done by handling these robots on one side with expressive anthropomorphic systems that are anthropomorphizing systems that are similar to the ones that are produced by external artificial empathy, related to system of emotional system for the behavior, to control the behavior of these robots that are not based on the imitation of natural emotional systems, but are all vaguely inspired by our or animal emotional systems, or are completely invented for these robots. And here we have many prototypes. The typical example I like to do is the robot that is produced by the Frank Hegel, that was created by the team in which Frank Hegel, that I mentioned before, is working. And this is Bartok Jr., the first you see in this slide, whose behavior is controlled by a program that is performing speech signal analysis on the speech of the users. And through this analysis, the program produces hypotheses on emotional state of the user, very simple hypothesis that can be happy, sad, neutral. And when there is an hypothesis about, the program reaches an hypothesis about the emotional state of the users, the emotion defined by the hypothesis is expressed by the expressive face of Bartok. So Bartok, in this sense, tries to create an affective loop by mirroring the emotions of its user. So also here, the relevant unit for the production of emotion is not the intra-individual space of the robot or of the user, but is the the space of the relationship of the interaction between agent and environment or other agents, and the process of expression of emotion is strictly linked to the process of production of emotion. So the idea I would like to propose is that if internal and external artificial empathy and also the affective loop approach at the theoretical level adhering to the classical dominant description, dichotomous description of emotion, the Cartesian view of emotion, at the level of the implementation, they are not implementing that view, but they're implementing a different view of emotion that we can call a relational view of emotion. Also, this view has a long genealogy. Even if it was not a dominant view, was a marginal view, is there since a long time. In the same years in which Descartes was publishing his treatise on the passion of the soul, Hobbes was publishing his treatise on the human nature, in which was describing emotions not as individual properties of human agents, but as relational properties of human agents, characterizing interaction between agents. And this is a view that is attracting the attention also of contemporary philosophy and also of some minor lines in embodied cognitive science, mainly radically embodied cognitive science research lines. And I would like to briefly present give you an idea of what is a relational theory of emotion by presenting Paul Dumouchel's relational theory of emotion that was particularly important for me, because when I started to explore social robotics, I was familiar with this theory. At the time, Paul Dumouchel was my supervisor for another research I was doing for the Japan Society for the Promotion of Science. And I had the impression that this theory was particularly relevant to interpret the way in which social robotics is implementing emotion in robots, so I involved Paul in this research project. And according to Paul Dumouchel's view of emotions, emotions are not private events, but are expression of a mechanism of inter-individual coordination between different individuals. And the idea is that emotional expression when we interact with each other is triggering a continuous process, is retriggering a process of coordination among agents in which we co-define our emotions, and through the co-definition of our emotional states, we define in a coordinated way, we co-define our disposition to action towards conflict or collaboration and their different declination. So emotional expression within this perspective is not only communication of predefined emotion, but is involved in the production of emotion through a process of direct determination. Basically, with this view, we switch from the scheme we saw before, the Cartesian process of understanding the emotions of the other, to a dynamic of continuous co-definition of emotions in which expression and production of emotions are inseparable, are intertwined, are entangled. And according to Paul Dumouchel, we are embedded in this dynamic since our birth, through the interaction with the mother or the caregiver, in such a way that this dynamic is influencing deeply our cognitive organization. And so is shaping all our interaction with the others and with the environment, also when we are alone. And in this sense, also when we are alone, our emotion have a social dimension according to Paul. So, and when Dumouchel is looking for neurophysiological mechanism that can support his his relational view of emotion and emotional processes, of course, is very interested by the mirroring mechanisms, mirror neurons and mirroring mechanisms studies by Rizzolati's group, and in particular by Vittorio Gallese's interpretation of the functions of mirroring mechanism. Also here, I don't have the time to go into details, but the main aspect is that Vittorio Gallese's interpretation of this function and Dumouchel's view of emotional processes converge in the idea that genuine emotions are not primarily internal, private, intra-individual events that then become through expression also external, social, and inter-individual. But they are at the same time internal and external, private and social, intra and inter-individual. For Gallese, through the co-activation, the neuronal co-activation we have through based on these mirroring functions, when we observe someone expressing an emotion, based on this, we cannot say that this emotion expressed by the other is an internal private event. It's already, is at the same time internal and external, private and social, intra and inter-individual. So, and furthermore, both Gallese and Dumichel converge in the idea that the relevant unit to understand, to make sense of emotional processes, to study emotional processes, is not the individual, considered separately from other individuals, but is the self-other environment interaction. And they also converge on the thesis that when we interact emotionally with each other and cognitively with each other, where emotionally and cognitively are not separated for these authors because they are there to the embodied view of cognitive processes, they self and other constitute subunits of a higher level units, in the sense that the agents that is determining the emotional status of the individuals while they interact is not the individual, the same individual, but is the interaction, the relationship between the individuals. So the agent that is distributing emotional states, emotional identities, that is defining the characteristics of emotional processes in A and B when they are interacting are not A, is not B, but is the relationship between A and B. This is the idea. And through this idea, they both generate the descriptions of the cognitive mind that are convergent with the description of the cognitive minds that are proposed by radical embodiment, that is the part of the embodied cognitive science that is refusing the computationalist description of us as cognitive agents, and is referring to models that are different from the model of the digital computer. And in my view, the view of the mind that best expresses this relational perspective on emotions, the one we saw already implemented in these robots and described by Dumichel or described by Gallese and other authors, is the enactive view of mind proposed by Francisco Varela. A view of mind, of the cognitive mind, according to which the mind is not an individual or separable organization supposedly located in the head or within our organism, as it is proposed by the mainstream of embodiment when it refers to still a computationalist view of the mind, the idea of embodiment, of embodying of the mind is that of basically locating this computational machine in the brain or within our organism. The proposal by Francisco Varela, the idea of the enactive mind, the enactive view of mind, is the idea that the mind is a structure of coupling, is a process of dynamic co-determination supported by the activity of the nervous system between all the systems that are involved in the process of our continuous production, self-production as biological systems in interaction with the environment and other systems embedded in the system, where basically the system are brain, body, agent, environment, world, and self, and other. So basically the mind is the unit of dynamic coevolution, brain, body, environment, others for each of us, which is supporting cognition as effective interaction in our domains of existence. A view of the mind that very effectively Francisco Varela proposed through these three sentences. The mind is not in the head, the mind is not inside nor outside, the mind is not mine, is nor yours. The mind is the brain, body, environment, others unit of co-dynamic evolution that supports our continuous self-production and production of our identity in interaction with our environment and other system embedded in this environment. So if this hypothesis makes sense, if artificial empathy is referring at a theoretical level to the classical view of emotion, but in its implementation, it's expressing a relational view of emotions, grounded implicitly in a radically embodied view of mind. So what this tells us about the future of social robotics and the future of artificial empathy and their impact on our social ecologies. And the idea that I would like to propose for debate is that if emotion will be explicitly recognized by artificial empathy as mechanisms of inter-individual coordination, then artificial empathy will lose any interest in trying to reproduce in robots our physiology of emotions. So as already are doing external artificial empathy and the approach, the affective loop approach in artificial empathy, to create robot-human affective dynamics, artificial empathy will not refer anymore to the synthetic method to reproduce our individual physiology of emotion here in individual robots, but will focus on creating specific mechanisms for human-robot emotional coordination to create dynamics of mutual transformation between the user and the robots that by creating emotional changes in the humans will coordinate the disposition to action of the human and the robots. So in this sense, if this is the trend, the direction of evolution of artificial empathy, we will have an explosion of lines of developments. And the best mechanism of human-robot emotional coordination, the best robotic platforms to achieve that will be selected by our history of coevolution with these robots. So the idea is that artificial empathy is evolving towards a pluralist approach that is already there, for example, for artificial intelligence. With the embodiment term, now we have, basically we don't have specialists in the cognitive science or AI that are convinced that when they talk about artificial intelligence, they're talking about a form of intelligence that is similar to ours. They consider that artificial intelligence, the intelligence that brings computer and robots to accomplish cognitive tasks, is considered completely different from human intelligence. And the same will happen with artificial empathy. The idea will be that of building human robots forms of affective coordination, specific human robots affective forms of coordination, completely different from the form of affective coordination that we have among humans or between animals and humans or animals and animals. It is that at the level of coordination, of the level of the interaction, we will have the recreation of certain aspects of the affective phenomenology that is typical of our interaction. But at the level of the mechanisms on which this coordination is underlying, we will have completely different mechanisms in the robotic agents and the human agents that are interacting. So the migration of the notion of empathy within the field of social robotics and human-robot interaction is creating new contexts for this notion. And empathy here refers to a form of affective coordination between humans and robots that is a dynamics of co-transformation between the agents that reproduces parts of the phenomenology of human-human, human-animal affective coordination, but leads the users to co-define their inclination to action according to the plans of social robotics in the direction of collaborative or supportive behaviors. I have still some minutes if you can follow me, but not more than 7 minutes, 8 minutes, about the implications. Okay, I'm sorry, I'm really sorry. So I think that this kind of exploration is very important for the ethical debate, has very important implications for the ethical debate. And the main implication is that it opens more options for the debate. That is, currently the debate is organized around a dominant position that is grounded in the dichotomous approach to the description of emotion, that is the classical Cartesian approach to the description of emotion, and that proposes a classical view of emotion that is declined here in an anthropocentric way. The basic idea is that these robots do not have emotions like ours, so they simulate emotions, so they expose us to false emotions. They cheat us in making us believe they have two emotions. I'm speaking the language of this dichotomous view, while they cannot have genuine emotion like ours. So we have to condemn all emotional robots as they are a cheating technology that is manipulating us and making us believe that we can have affective relationship with this technology, while this technology cannot establish affective relationship with us. And also it's a technology that in the long term will damage our social bonds, because more and more we will prefer to interact with these machines that with other humans, which is much more challenging. It's easier with the machines, and more we will prefer to delegate our relationships of help to this machine. So we will expose vulnerable people to the affective interaction to these machines. So the outcome of this position, and the more coherent outcome, is that of banning, condemning in a more general way all this kind of robots without any analysis about risk and benefits that this technology can have. And this implies that this kind of ethical approach does not engage in the elaboration of ethical guidelines to orient social robotics and artificial empathy in the construction, in the design, the construction of the robots. This implies a significant risk, the risk of a production of robots that is completely decoupled from ethical reflection on these robots, that does not have any ethical guidelines and is driven only by the request of the market. And considering that today, for example, in the market, we have the commercialization of robots on which we are stimulated to exercise violence, and considering also that many studies are telling us that social robotics succeeds in making us perceive these robots as social partners, not as other people, but not as objects, something in between that the people interviewed define as social partners. This has to be considered something that we have to analyze very, very carefully. The problem is that a general condemnation of social robots that intervene a posteriori to condemn a priori all the production of social robotics and artificial empathy will remain unheard by social robotics. This is the real problem. So if ethics does not engage in producing guidelines, we will not have guidelines, simply the production driven by other kind of guidelines that are not ethically grounded. So this is the risk of this position. The kind of philosophical inquiry I propose to you is generating another position in this, within this, the ethical debate on artificial empathy, that is based on a relational view of emotion and the pluralist approach of emotion. An example of this approach is the synthetic ethics approach that we are developing with Paul Dumichel. That is an ethical approach that is recognizing that we are engaging in a form of affective coordination with robots, is not denying this, is not considered this false forms of affective coordination, but specific human-robot affective coordination, forms of affective coordination that we have to study And so it is analyzing the specificity of this rigid, very limited form of affective coordination in order to consider case by case within specific projects the risks and the benefits that the applications produced by social robotics and artificial empathy can generate, and proposing a concrete solution to minimize the risks and maximize the potentialities of this technology. So the idea is that of moving from the individuation of the risks that the traditional approach, the dichotomic approach, the dominant approach has the merit of doing very well. This approach, the approach I presented before, the dominant approach that, for example, is expressed very well in Sherry Tarkle's position, has really the merit of individuating risks that are inherent to this technology. But the idea of synthetic ethics is that of moving from the individuation of the risk to the definition of research question to be addressed with specialists in social robotics in the lab while we are ideating, constructing, testing social robots. How can we avoid the risks of affective child-robot interaction? And we can develop robots that instead of acting as social isolators can act as social connectors, that instead of offering ways of escaping from human-human relationships are encouraging this relationship. How can we address the problem of emergent behaviors, ethical behaviors or ethical conducts that are emerging from the interaction with social robots without being able to predict that? So the idea is that of applying the synthetic method of the sciences of the artificial to the study of our ethical behavior in the context of human-robot interaction with the help of the specialists in social robotics and other sciences to, on one side, improve the ethical dimension of social robots, improving this technology with regard to this ethical dimension, and on the other side, to understand better our ethical behavior in the interaction with this robot, which is urgent considering that these robots are already in our social context. We don't have any idea of how they influence our ethical conducts, our choices of values while we interact with them. So the idea is that instead of banning social robots, trying to use these robots as tools of self-knowledge and tools of positive developments and moral growth, following the indications of an ethics of a complex system, of self-organizing system, or of observing system that Alphonse Förster proposed in the context of second-order cybernetics, was very close, to which Francisco Varela was very interested, and that is the ethics that proposes to us to always maximizing our possibilities, always maximizing, augmenting the possibilities of complex system, self-organizing system, observing system of ourselves. Possibilities that are always, in the case of complex systems, self-organizing systems, of observing systems, possibilities of coevolution. In this case, I'm referring to the coevolution among us through social robots, and to the coevolution among disciplines, social robotics, but also epistemology, philosophy of science, anthropology, psychology, sociology, design, contemplative sciences, for our self-development through this technology. So I thank you very much for that attention, and also for following me for this very long talk. I would like to underline the take-home message that my talks would like to offer also for debate. It is related to the critical importance of the epistemological and theoretical choices we make, especially with regard to artificial empathy and on the debate, in the debate on artificial empathy, because different epistemological and theoretical views of emotions imply different robotic technology, but also different ethical approaches, different regulation approaches to the social sustainability of the diffusion of social robots, and so can have concrete implication, concrete impacts on our future and the future of our context. So thank you very much for your attention. And again, sorry for this very long talk. Thank you.
Wow, thank you. Thank you so much, Luisa, for this extremely deep and wide summary of your research and work, and quoting many of your colleagues that you are working with. I think we would have proper time still to have a good discussion with you. So I'm inviting all our friends here to think about your talk and your proposition, especially the meta level, I think, that you proposed in the summary slides, so that we can really understand not only the importance of your work, but the huge consequences that such a work may have on our own self-understanding, who we human beings are. And my understanding of your talk was that without addressing the issues and questions of social robotics properly, and without developing this field, we may lose a huge opportunity of self-understanding and self-development for us human beings and human societies on the longer run. And this is a very interesting and important proposition or statement that I heard or understood from your talk. And thank you so much for making the case for this whole discipline and interdisciplinary research on social robotics.
Thank you so much for summarizing this so in such a beautiful and synthetic way, which I would never be capable of.
No. It was your summary, I think. So thank you very much. And I'm now very much interested in all comments or questions or challenges that our friends here may raise or pose. So please feel free to just simply dive into a discussion.
I'm curious to see some videos. I can find some videos and show and share videos with you in case.
Thank you.
I see. In the meantime, I look for videos then.
Sure, thank you. So Ruben, the first question is yours.
So thank you, Gabor, and thank you, Luisa, for this very interesting, thought-provoking talk. There's one question that comes to mind is, what type of ethical traditions have you found most helpful to think about this set of questions? And I'm wondering in particular about the feminist ethics and ethics of care as a way of thinking about, for example, the relationship with robots in fields like healthcare and care more generally. I'm not sure, I don't know anything about this area, so I would be curious to know what.
Unfortunately, this is not my area, in the sense that I arrived to the ethics of social robots through epistemology and philosophy of science. And what I met in this debate is a tendency to reproduce, to take solutions, ethical frameworks, for example, from bioethics that were developed for completely different problems to approach these problems. So I tried even to stay far from traditions, because there is already the tendency to avoid the production of novelties, of ethical novelties in this field, and to try to give insights from an epistemological point of view. So in this sense, for me, every ethical tradition is very interesting and can contribute once we understand that we have to create novelties to address new problems, and not simply to apply ethical schemes that we already developed for other issues to these issues too, because I don't think this is the right way to go. But unfortunately, I cannot tell you about what this kind of traditions can apport specifically to the field, because it's a different angle. It's not my field. I would have liked to avoid to say things that are not appropriate.
No, sure. No, I think I know what you mean. No, but thanks for that. I'll lots to think about.
Thank you very much.
Thank you, Ruben. Catherine.
Yes, thank you, Luisa, for this presentation. I was wondering, it's a little bit close to what Ruben asked you, but you mentioned the GSPS, Japan Society for Promotion of Science, and I was wondering what kind of work they have been doing in that field. I mean, you just said that you arrived in a different angle, but maybe working with those people in Japan with the GSPS grant, maybe you had some information about how they feel about this field of ethics with the robots in that particular area.
So thank you very much for the question. The Japan Society for the Promotion of Science indeed is a funding society that is not focusing on this kind of issue. So what I loved of this society is that when I was proposing in Europe this kind of projects studying artificial emotions, especially to a funding society related to philosophy, this was considered not interesting. While the Japan Society for the Promotion of Science immediately gave us the grant. And so we could go through to visit all the labs in social robotics in Japan and to really make an in-depth exploration and work on this topic. And this starting in 2007, they give us a 2 years grant. And we are still going on because this was so interesting. So from them, we really, maybe the main message of the Japan Society for the Promotion of Science is the openness to, the Japanese openness towards technology. So while probably in Europe, this was considered a topic that was not worth originally the idea was the operationalization of the notion of empathy in the field of social robotics. This is what we proposed. In Japan, this was considered very interesting, but also because there is a different angle on the role of emotions, the role of technology in our life that is less technophobic than what we have in Europe, but maybe less critical also. So too much enthusiastic acceptance without criticism on that side.
Thank you, Luisa.
I hope this is what I can answer. I'm sorry.
Thank you. Aude and then Bruce. Bruce made a good comment in the chat that we can probably hear about. But before that, Aude.
Hello, Luisa, and thank you so much for this talk. This is very far from my domain, so I will have to watch and rewatch this video. I have a question, however, you said, and maybe I'm wrong, but you said that adding emotion on robots, for example, fear, would make them react faster than analyzing everything. And if that's correct, indeed, I'm not sure I fully understand how they can be faster aren't they analyzing in both? I'm not sure you understand my question.
Thank you very much for the question. Then I want to know what is your field. But so the answer is, this is a programmatic idea. Is the idea that if they could react as animals react or humans react to a dangerous situation, then they would be much faster in changing the priorities, the order of the priorities in their behavior. But for the moment, we don't have prototypes that are doing that. So we have architectures that are drawn on paper. We have simulations of these robots, but we don't have robots doing that at the moment. But the idea is simply that a robot now to understand that there is, to detect a danger or have a direct a sensor to that specific thing, or would have to go through an analysis of so much data that would never react on time. This is the idea. So maybe a natural-like system could change this in some way and make these robots more autonomous, more flexible with regard to the order of priorities and their behaviors with a changing situation. Because at the moment they can perform well if the situation is basically static and not changing. So there are very rare occasions in which they perform really well.
Thank you.
Thank you.
Bruce.
I think I don't hear.
Not yet. Bruce is working on unmuting himself. Yes.
Okay.
Okay, right. Hopefully I'm unmuted. Just before we leave that last topic, actually, fear is a mental representation of the activation of survival mechanisms in the human body. It's simply the description that we apply to the embodied reaction to precarious situations. Basically, if one was able to create that artificially, we would actually be looking at the process of autopoiesis, which is a process dependent on making adjustments to precarious situations as originally defined. And basically, you then no longer have an artificial life form. You actually have an autopoietic life form. So I think to actually make that step, I think the problem here is with language. We're using fear. We're using the whole context of emotions as a category, but it's not a category. A lot of the individual human responses are actually based on survival mechanisms. Anyway, that was just an additional comment there. The other, well, perhaps related to that, actually, thank you for your discussion. And you kept going back to the classical forms, which are basically Cartesian duality. Or the which has been is the philosophical view of the mind as machine, and this has historically the study of cognition excluded emotion, focusing on non-emotional processes, memory, attention, perception. I put some references up in the chat. So scientists of this classical era were influenced by the philosophical view of the mind as machine, and considered the mind to be a simple linear system, which could be reduced to its component processes by analysis. And this is what a lot of artificial intelligence is based on, the assumption that one can do the same with a computer. However, as evidence developed of the overlapping of cognitive and affective neural circuitries, mental processing came to be recognized as a complex system, which led neuroscience and neuropsychology to integrate the cognitive and affective processing systems and effectively redefined affective neuroscience as the cognitive neuroscience of emotion. So my question to you is, given these evolving views, the way that we've moved on from the classical view, these views in the hypothesis, what are the hypotheses of human cognition, affective and social functions, which you were referring to earlier on in your discussion, that have been incorporated into social robotics?
At the moment, as I said before, the most developed parts of social robotics are the affective loop approach, the external approach that are based on this, are focusing on expression of emotion and inventing some emotional system for robots. So in this sense, when we have prototypes, social robots, we don't have still the implementation of specific theories of the generation of emotional processes in robots today in social robotics, because the lines that are trying to do that are still not producing artifacts. The approach that created the robot I showed you before in the picture, Affetto, for example, this was an approach that is very close to an action, so to radical embodiment, and also to a relational view of emotion, as I delineated this before. But in general, I imagine that the attempts that are in other branches of artificial intelligence are shaped by the approaches you are referring to. For example, computer programs that are emotionally interacting with their users. I tend to think they incorporate insights from affective neuroscience, from computationalist affective neuroscience. But in the field of social robotics, these attempts of implementing systemic approaches and to recreate the emotional physiology of humans in robots are still far from producing anything. And also, as you said before, or as you solicited me to think before, I don't think we will never arrive to produce a robot that is an artificial form of life in an autopoietic sense, that we will be able to reproduce something like our metabolism in a robotic machine or even a synthetic biology machine. So in this sense, they are doing something, in my view, that cannot bring to concrete results. So it's the kind of research that, as I also try to project through my hypothesis, will not have a future.
Yes, I think I would agree with that. So effectively, what the social robots are doing is they are creating a stimulus system, which is hoped will change the neuroplasticity of the human in the equation. But that's not co-evolution or co-definition, as you described. It's simply creating a desired response in the human, you know, to start to map the social brain areas or to activate different relational areas. It's simply an external, non-living, obviously, stimulus rather than any sort of co-development between two entities.
If I define, yes, I agree with what you say. If you watch it from the point of view of what is coevolution between biological systems, I agree with you. We are not talking about a form of this kind of form of coevolution. But if we consider coevolution through an autopoietic definition, like reciprocal perturbations and internal self-regulations that create coupled conducts, then I think we can think to these robots as robots that are starting a very rudimental and very limited, very rigid form of hybrid biological robot or human robot coevolution in this sense. And I see in this the beginning of a possibility of evolution of the field that is much more effective than the attempt of recreating our emotional physiology in robots.
Yeah, so if,
for example, a robot that learns from its user the fear for something, in this sense, as an affective coordination with the user, then can react more quickly to a dangerous situation in the definition of the humans than a robot that does not have this kind of coordination. And to this, I think we can arrive in some way. Also with mechanisms that are not trying to reproduce biology into robots, but are trying to create something different that can co-evolve through mutual perturbation and self-regulation processes with robots, with humans, sorry.
Well, so if we're going to do that, we really need to stop using our human emotional terms, maybe look at what each of the individual emotion actually is. And for example, where fear is the possibility of not surviving because of a precarious context developing, maybe we need you need to redefine that for the robot as to what would be a precarious survival threatening situation, and that would equate its experience with fear rather than trying to translate our own outward presentations of fear, which are simply just going to be imitative, and whilst they would be useful in neuroplastic change in the human, are not actually creating any change in the robot. But I agree, it's early days, but maybe the field needs to follow a different theory rather than following human philosophy.
This could be useful. And in my view, the problem applies also to artificial intelligence. And if we need to differentiate our vocabulary, we need to start from there, because usually a difficulty that I meet discussing, for example, with people that has the Cartesian view is that they say, no, intelligence can be reproduced in robots, emotions not. But in both cases, we don't have anything that is natural-like in our artifacts. So we are really building something different, and we have to target the construction of something different that can interact well with us and bring us towards our self-development, as I meant before. So thank you so much. This is super interesting.
Oh, no, just to say one thing, I think one of the problems is conceptualizations, and conceptualizations including language and mathematics actually limit the experience that the human is trying to express. So sometimes we need to look at what the experience is that we would like and use perhaps a different system of mathematics or language to nudge the other, whatever that other may be, towards the experience that we're actually trying to equate. Anyway, thank you very much for your talk, which is very interesting.
Thank you very much. I also think that in the case of the robots we can build, the fear would be always the fear of the human that the robots could learn about, no? Because at the end, it's yes, a social partners, but a tool social partner, not a social partner like other humans. So the focus should be always on humans anyway.
Well, fear basically comes down to fear of not surviving. The brain is designed for survival, not for understanding itself.
So this should focus on the human survival, not on the robot survival.
Well, any survival, if you want to use fear, basically it's a precarious situation, as I said, in relation to autopoiesis. But one interesting definition, as I say, of the brain is it's designed for fear, not for understanding itself.
Yeah.
I think this is what is at stake here in this particular development. And that's what I found enlightening in your talk, Luisa, that the whole dimension of social robotics, and actually AI as well, will be defined by what we think we are and who we think we human beings are. So we will design these robots and artificial intelligence in the way how we understand ourselves. And that's where ethics come into the picture. And that's where a lot is at stake. If you just look at this current the situation with the war, how we simply are, human beings can and are able to objectify and materialize other human beings, killing, suppressing, raping them. This tells a lot about who we are and what we are capable of doing. So this is another dimension that you highlighted to us, I think, where whatever development will happen, that development will shed light on who we human beings are and how we consider our values and our ethics and our principles and our behaviors and our connections with each other and with other non-sentient existence or beings like robots. And that in itself will tell a lot about us and what we can do and what we cannot do. So this is for me goes beyond the concrete biology or the concrete possibility of a certain biology of robots and self-understanding of robots. It will tell us a lot about how we evolve and how we can also reshape our understanding of what the other is. And that's not taken for granted, at least not in this point in time in history, where we are still not able to respect the other properly in cultural and historical context. So it's going to be fascinating. And the models that you are developing, the very model, this affective loop model, seems to be very promising, not only in the context of social robotics, but also in the context of interhuman relations. So it would be good to come back to the interhuman relations with this model in mind and develop a new form of ethics that that Ruben was referring to. So I think the potential in this very question is huge and goes way beyond what is implied here in the context of social robotics. And this is very interesting that this comes back from this dimension of work with the robots. And that also tells a lot about us, that we need to address robots and artificial intelligence in order to be able to understand who we are and design an ethics that goes beyond the classical forms and the challenges that we faced in our human history.
To observe ourselves through the eyes of the other, no? We're saying Maturana and Varela and Heinzmann first, and this is the process we need. But another important point is that it's very important for the development of this technology, the human sciences and all the sciences enter and give contribution, because it's important that while designing this technology, the question of who we want to become through these robots is a question that we have to keep in mind. And often is neglected if you are focused only on technical aspects or the user comfort or aspects like this. So we need really to put these philosophical, epistemological questions, anthropological questions into the design of these robots. And for this, we need a different kind of setting for the construction of our technology, the design of our technology. We really need transdisciplinary approaches, concrete transdisciplinary approaches to be there. And that's why it's a pity that many specialists in anthropology, in sociology, in philosophy are simply refusing to deal with these technologies and simply condemning them, because they will not disappear, simply they will be developed without these contributions.
Thank you, Luisa, and thank you everyone here for this very engaging, interesting discussion, dialogue. And I hope it's not a hope, actually, it's a promise that once we are able to rewatch this talk, we will be able to explore more and more and more. And one thing became true or became clear to me, that whatever we do with this area of development or question, we will be involved in a social coevolution or a social co-definition with whatever robots we are going to develop. But that means that we are going to be engaged in a coevolution with ourselves. And there's a lot at stake in this particular period of time. So I just wanted to highlight that personal feeling of mine that your talk contributed to.
Thank you.
Thank you so much, Luisa, and thank you everyone, Ruben, Catherine, Bruce, Aude, Edel, Martin, Annie, and Amy, who were here during this particular meeting. And we will send you the recorded link, the link of the recording in another email in the coming days, not only to you, but to all our MLE friends and the larger community, so that we can rewatch and think about this question as we progress. And we wish you all the best, Luisa, in this particular research and in all your collaborations. It's going to be crucial, I think, the coming years and decades. Thank you
so much. Thank you so much for having me here. It was super interesting. Thank you. Thank you very much.
Thank you. And thank you all. Now I turn back to Johanna so that you can hear about our upcoming talks. Just a minute before we finish.
Thanks, Gabor, and thank you again, Luisa. So just really quickly, we have 3 upcoming talks actually in the next 3 Wednesdays, all at 6 p.m. Central European Summer Time. So the next talk we have is actually with Dr. Richie Davidson. So this is an exciting occasion to hear from him in a smaller format audience. It'll be part of our Francisco and Friends series. It's a public talk, and it'll be specifically reflecting on his trajectory in light of his relationship with Francisco Varela. So some of the things we talked about this evening will certainly come up again in this talk, some of Francisco's ideas. And then we have another Francisco and Friends webinar with Adam Engel, who's one of the co-founders of Mind and Life, both in the US and in Europe. And so he'll be speaking on May 11th, also at 6 p.m. And we will have a community of contemplative education talk on May 18th. This is a particular series of talks, which you're all invited to. And it specifically reflects on research areas around mindfulness and related fields in the educational setting. So we have Anna Bornstein, who's actually a Swedish writer and journalist and entrepreneur who started a major initiative in Sweden. And so she'll be talking about her project, and you'll be receiving more information about that. So that's May 18th. So please feel free to join, and we look forward to seeing you soon. Thank you so much.
Thank you.
So once again, thank you, and we can stop
Thank you
the
very much.
recording.
Bye-bye. Bye-bye.